Okay, so I want to continue to build on this particular platform. A few things have changed. Actually, really only one thing has changed since I left this video off. I decided that I may actually want to do some more cool stuff, like maybe make it Bluetooth controlled or maybe RF controlled or something like that. So I wanted to have one of my newer motherboards. The motherboard that we were playing with before was for a 3.2 like this one, which is perfectly fine, and actually it's not really that much different than the one you see down here. This one has a lot more I/O and a built-in SD card, but ultimately we're not going to use any of that. We're going to be using just essentially the front half, okay, which will be wired identically, function identically. This really isn't any different. But what this new motherboard has here is it has this additional port, which is going to allow me to hook up things conveniently, like the Bluetooth or the RF. My new motherboards all have that port on there. It's just at this location I don't have any more of the 3.2 boards that are ready to go. So that being said, I've swapped it for a 3.5 board, and it does have this additional port. Other than that, the wiring's the same. I put everything in the same place. So let's take a look. If I turn it on, I've already loaded the code we were playing with, and it's doing exactly what it was before. You can see that it's driving the motor, and we see the left-right, although you can't see it. The wheel's turning down below, but you can hear it when it fires up. Okay? So what I want to do first is clean up this code a little bit, because this is really horrible code. I would fail myself if it was in my own class. What I want to do is I want to put some variables in here. I want to break this into functions. I want to do a bunch of stuff. The first thing, though, what I want to do is figure out what is doing what. Because you recall, I have no idea. I just wired it in and then turned it on, and now it's up to the code to tell me what is actually happening. So I'm going to put this over here so we can kind of share the screen a little bit. And what I'm going to do is I'm just going to comment out a whole bunch of this. See if I can get it to, oops, for some reason it's paused here. I tell you what I'm going to do. I'm going to pause this video and figure out why my icon is frozen. So give me a moment. Okay, I'm not exactly sure what my computer was doing, but I temporarily lost this. So I'm just going to go ahead and comment this out, because I have no idea what this is actually doing. I hooked it up to something. I don't know what. So I'm going to turn off the power to my motors. Okay. And now I'm going to go ahead and upload this piece of code. And we're going to find out what a high-low on pins 9 and 10 actually does, and then I'll create a function for it. Alright, so I'm going to pause it while it uploads, and I'll be back in a second. Okay, so it's done uploading, and we'll turn it on, and we're going to see what this does. Alright, so it seems to switch the direction of the wheel, and I suppose that if it's turned this way, it's going to cause the robot to drive over to the right. So this would be a turn right. So I'm going to make a note on that right now, just so I don't forget. Okay. I think we can safely assume that 9, 10, low, high, I guess I can test it. My guess is that this is going to be a turn left. And I'll load it just for snickers and giggles, and we'll make sure. Sure enough, that's a turn left. Okay, so I'll make a quick comment here. Alright, and then that means I know that this is straight. Okay, and I can assume then that this is drive, so let's turn this one, we'll comment this one out, and let's bring this in, and let's see what it does. It must be one of the drive wheels. And you can't see it, but this is turning the wheel in such a way that it would go forward. So I'm going to comment that. Forward, I can't spell. Throw a W in there someplace, come on. And I'm going to guess, in fact I might not even, well, we'll test it, but I bet this is a backward. And then this would be a stop. So let's go ahead and give this a quick test. I'll comment this out. Turn that one on. Sure enough, that's a reverse, and then this of course would be stop. So we've got enough information here. Let me turn off these motors, which again I can do with this switch right here. And now it's time to actually build this. So we now know that 9 and 10 are for steering. Okay, so I'm going to make up here, I'm going to go ahead and make a constant, some sort of global. So I'm going to call it a constant. I'm going to make that lowercase. And let's call it, well, it's going to be, we'll make it a constant integer. And let's call it, I don't know, I'm going to call it T1 because that means for turn 1, because we're going to have two different pins, right? Remember, we have to go like this, one high, one low to make it turn one way, one low, one high to make it turn the other. So I'm going to call that T1 for turn 1. And what I'll do is I'm going to set it equal to 9. So it's going to be equal to pin 9, which is where it's plugged in. Okay, so essentially I'm going to have that be T1. And I'm going to go ahead and copy this because I'm going to make a T2 for turn 2. And it's of course going to be 10. Okay, and then what we're going to do is we want to have another set of variables. I guess I'll go ahead and put it right here. And let's call this drive. And drive 1, and it's going to be 11. And then I'm going to copy this. And we're going to make a drive 2 pin, and it is going to be 12. And then I'm going to make a couple comments, tidy that a little bit with a Control T. And then what I'm going to do is I'm going to make this T1. I'm going to make this T2. And I'm going to make this drive 1. And I'm going to make this drive 2. I'm going to add a couple more comments to this code, and I'll show you what I do in just a moment. Okay, so I've added some comment to the code just to make it easier to read with a double slash mark. So I'm telling myself, my future self, and for anybody else who might look at this code, oh, that's right, so pin 1, pin 2, pin 1 and pin 2 for both turning and drive. And then I set all of those to output. Okay, so I haven't changed any of the functionality of the code. It should essentially run and compile and do everything it did before. I haven't tested it. I'm certainly hoping nothing has changed. And we'll turn it on. And oh, what am I saying? I got everything. I have all of this blocked out. So let's just go ahead and bring one of these back. And we'll load it up again. And we should see it move to the turn right position. Okay, so all that's super. So now what I need to do is create some functions. Let's think about it. I mean, ultimately, I want to go forward straight. I want to go forward to the right. I want to go forward to the left. I want a dead stop in the middle. And then I want the same thing in reverse. I want to reverse right, reverse straight, and reverse left. So I need a total of 7 functions to break that up. Okay? So let me copy and paste that and make some functions, and I'll show you what I did in just a moment. So I'm going to pause it again. Okay, so I've started to create one. I've only done one so far. And all I did is I said I want to go forward and turn at the same time. So I copied these 2 lines here, and I pasted it down here. And I copied these 2 lines here and pasted it down there. And I made a function, this void turn right function. Okay? And it works just fine. If I load this up, I've commented all this out, so the only thing it's going to see is this turn right. If I move this over, actually we'll just minimize it. Take a look here. If I turn it on, it immediately snaps to the right, turning right position, and you can't see it, but the wheel is now pushing the robot forward. I have it propped up so it's not touching the surface. Okay? So the only other thing that would be nice is notice how I had these delays afterwards. Okay, so we can set how long we want it to turn. I think I'm going to do that here, except I'm going to do it with a argument. So I'm going to make a little variable here. I'm going to call it delay. All right. And then what I'm going to do is I'm going to put down here delay for how long? Well, we're going to delay for my abbreviated funky delay. Okay? So therefore, if I put in here a 100, or maybe let's go with 500 for a half a second, it's going to take that 500 and pass it into here, and then carry it down to here, so it's actually going to call this code, let me turn this off, for only 500 milliseconds or half a second. But I haven't told it to stop, so this is going to remain the state, okay, regardless. I'll show you. Let's load this up. It's going to just run, even though I've only told it to go for a half a second. Alright, it's going to run continuously because I haven't given it a way to turn this off. Alright, so I need to turn that off. I need to make my stop bot. So I think I'm going to do that actually next. And I might even do it, I should have done it almost first. We'll take a function right here and let's call it stop bot. And my guess is I'm probably not going to need to stop for a short period of time. I'm probably going to want to just stop. So I'm going to get rid of this delay altogether. I can always code in a delay like I did here. And remember that to make it stop, you just have to set everything to low. Okay, and it should turn off. So now I'm going to take this stop bot and I'm going to paste it right here. And to make sure that we actually, to make sure we actually believe it, I'm going to put a while true here. So it's going to be an infinite loop. So once it reaches this point here, it's going to get stuck in a loop, and that'll be it. So it's only going to run one time. So let's load it up and see. I'm going to turn it on. And, what did I forget? Oh, look at that. I forgot a semicolon. Let's try that again. And you can watch this. It should happen. There we go. Perfect. It went briefly for half a second to the right. Okay? So that piece of information, what I'm going to do, and then it stopped, and then it entered an infinite loop. Okay? So it made it no further. So I'm going to go ahead and create that total of 7 of these functions. So ultimately I'll need, I'm going to create 7 total functions. And I'll see you guys in just a moment. Okay, so I've completed writing the 7 individual functions. And so I've got a stop bot, a forward, a turn right, a turn left, reverse turning right. By the way, these are going forward, turning left and right. A reverse turning left, and just a straight reverse. So if I load this code up, well, actually, let's look at the loop. And what I've done is I've called them all. I chose different times, so it's going to go forward for 1.5 seconds. Turn left for 800 milliseconds. Turn right for 500 milliseconds. Reverse for a second. On down the line until it hits stop bot. Then it enters an infinite loop. So we're going to see this thing kind of move through a variety of things and then just simply stop. So I'm going to load it up. And we should see it, might be able to hear it more than anything. It's going forward, because it's turn, turn, reverse, turn, turn, and stop. Okay? So now we have a piece of code that we can build upon. We can call these functions and make everything really slick. Okay? So let me pause this and decide what I want to do next, and I'll see you guys in a few seconds. Okay, I've decided I wanted to add a little piece of code to make the onboard LED flash a couple times so I can upload the code and not have my robot take right off. So I wrote a really simple piece here. There's an LED built onto the Teensy. It's on pin 13. So I declared it as pin 13. I called it LED. Then I set the LED to output because I have to do that to turn on and off the LED. I have to make it an output device. And then I created a really simple loop, which is going to, for a total of 5 times, simply turn on the light, wait for a half a second, and turn it off. So if I load it up and we watch it, you'll see the light flash here 5 times, and then the robot will begin to move. So I'm going to run out of time here. Oh, and I don't have the power on. Okay, and it would have worked perfectly.